This is bonding video number 4. By the end of this video, you're going to be able to determine the Lewis dot diagram of an ionic compound. This is a metal plus nonmetal, and will be different than the covalent molecules we've talked about in the past. In the past, we had shared electrons. Here we're going to show how the electrons are going to be transferred from one thing to the next. To do your work, you want to have your bonding video number 4 worksheet available. You're going to need a pencil to write down the information because you will be turning this in, and you'll probably want to have your periodic table available so you know how many electrons are available. Let's get started. In order to find out the ionic bonding, you first need to be able to figure out which ion is most likely produced. To do this, you want to start off with what does the atom look like. So Lewis dot diagram wise, lithium had 1 electron that was valence, magnesium has 2 valence electrons, and oxygen had 6. Now we want to find out the octet rule. During covalent bonding, we talked about them sharing electrons to reach the octet. Here they're going to be gained or lost because we're transferring the electrons from one thing to the next. For lithium, in order to get 8 on the outside, he can gain 7. The other option, though, is to lose the electrons on the outside energy level and have a new outside energy level. So we could lose that one lost electron. Between the two, it is easier to lose 1 than to gain 7. The number is smaller. So when he's done, he's going to lose this electron. He's going to become lithium. Notice the electron is gone. We're going to put brackets on the outside to show that this is now an ion and not an atom. Na plus 1 charge. This is what the ion looks like. So we've gone from atom to ion. Magnesium, same idea. He has 2 electrons on the outside. He could lose those 2 electrons. Or he could gain 6. Two is less than 6, so he's going to gain 2. Lose 2. When he's done, the 2 electrons are lost. We don't write them down. Brackets to show it's an ion, and plus 2 for his charge. Now if you notice, the plus 2 and the plus 1 charges are the same thing we had last semester when we talked about the nomenclature. So we've gone from what the atom looks like down to what the ion looks like. Oxygen, other side of the periodic table. He has 6 to start with. So he could lose those 6. Or he could fill in the empty 2 spaces and get 2 gained electrons. Between the 2 items, 2 is less than 6, he's going to gain 2. So when he is done, he has all 8 electrons visible. He has his brackets around him and a negative 2 charge. So he went from atom down to ion. So how does this look for the ionic compounds when you have more than 1 atom put together? Potassium. He's in the first column. He is going to be a plus 1 charge. So ion-wise, he is a plus 1 charge. Notice, no electrons there because he lost them. The oxygen is going to be a negative 2 charge. He's going to gain electrons. So all 8 will be filled up. He's a negative 2 charge. And as we talked about earlier when we talked about naming things, a plus 1 and a negative 2 does not add up to 0, which is why we're going to end up having that second potassium ion. Last thing to notice, plus 1, negative 2, plus 1. We want to alternate them. We don't want to put the 2 potassium side by side. because they would repel. We want to have it go plus, minus, plus. Always alternate your charges. Okay, magnesium and chlorine. Magnesium was a +2 charge. He was in the +2 column of the periodic table. He has no electrons because he lost them. He's a plus charge. Chlorines have gained their electrons. They now have 8. -1. Now we're alternating where things are located, but we don't have to go straight across. We do want to follow like a grid path. We want to go straight lines up and down. So we could put the chlorine down below if we wanted to. As long as we're alternating between the positive and the negative charges. And this is a finished magnesium chloride. A couple things to notice here. The positive ions always ended with no electrons around them because they lost the electrons. The negative ions always end up with all 8 because they have gained electrons, which is why they now have a negative charge. So over here with the aluminum and the sulfur, we know the aluminum has to be the positive because we always start with the positive, then we go to the negative. So we're going to have our aluminum, our sulfur, our aluminum, our sulfur, and another sulfur. We can put the brackets around them. Next we want to know which one is going to get all the electrons. The negative one always gets the electrons, and the negative one always comes second. So the second guy is going to get all 8 electrons around him. Now we need to know what these charges are. Back in the naming days, we know that the sulfurs were -2s for the periodic table, and the aluminums were +3. We are now done. This concludes the end of our bonding video number 4.